Hi guys, so today we're going to see how to use an ADC with X2C model-based approach using a dsPIC33 CDVL evaluation board. So as we see, when opening MCC and having done all the X2C previous configuration, we can open ADC examples to see how to use the ADC. By clicking on the examples, we can select the available, the basic printf example just to see a guideline on how to set the ADC to have what we want to see. In our case, we will select pooled ADC, but for having a better X2C implementation, it's better to use a callback and call the ADC with an interrupt. But in this case, just for ease of understanding, we'll use pooled configuration. After doing this, we can see on the bottom right corner all the instructions to set the ADC. So as the first thing, we have to add an ADC multi-core, we add the driver, and then we go and follow the next instruction, which will be the ADC channel that we want to use. So in this case, we have to check the datasheet of the dsPIC33 CDV and check which ADC we want to use, and in our case we want to read the values of the potentiometer. So we see that the value of the ADC is AN15, so we go in MCC and we select AN15 and we enable it. After doing this, we go to the ADC example reference and we see that we need to enable common software trigger in the ADC configuration. So we go there and we enable the common software trigger. One last thing that we do is the change name of the ADC channel to pot1 to have a better abstraction of the potentiometer reading. Now we are ready to generate a code. So we go on the top left corner of MCC and click generate. The code will be generated and we will follow the instructions on the example. As a first thing, we include ADC header, just as shown in the example. After that, we create a global variable called ADC result, and subsequently we open X2C main.c. Once here we include the ADC whole, and after that we add ADC result as an external variable, and we add the structure of the ADC interface, just as shown in the ADC example generated by MCC. In the update imports, since we want to read the value of the potentiometer. Since we're in polling mode, we will enable the software trigger enabled to read from the ADC, then we'll wait for the conversion to be done. So we'll add that while loop, and after the conversion is done, we'll pass the value of the ADC conversion to the variable ADC result. Note that this is only used here as an example for better understanding of this code, but in using X2C, it's better to use interrupts to read from the ADC and update the variable. After all this is done, we can generate the code and see if there's no mistakes, and if there's no mistakes, we can open MCC again to go into Scilab X2C and add the potentiometer input in the state machine generated by Scilab. So we wait to open MCC, and once MCC is open, we can open X2C and open the model generated with X2C. Note that all this X2C generated model was done prior to the beginning of this video, and you can see my older videos to see how to generate a model from X2C from zero. After we open this model that I generated, we can add a new import, which will be the potentiometer import. So we add import, we double click to call it potentiometer, and you also need to connect the red line to the clock. After doing that, we will try to use the potentiometer to toggle a LED depending on the value of the potentiometer. For this, we'll use the auto switch and add some thresholds, preliminary thresholds. Then we will change the thresholds depending on the X2C scope values, such to adapt correctly to the right thresholds for the values that we want. Now we can start communicator if it's not open already, and then transform model and push to communicator. After the transformation is done, we can open the X2C communicator window that appeared and generate the code by clicking that button. After that, we can go to MPLAB MCC, reload the I/O ports. As we see, the two new input and output ports were generated. We can go back to X2C main without having to generate the code again, and we can add the import and the output of the X2C model. So one is the X2C model import that will be saved in the pot out input, and we'll save the value of ADC result directly. While for the output, we'll want to have the LED2. For the LED2, we also have to enable it as an output in MCC, which if you didn't do, I suggest you to do it directly there. After having that, we can use it, and we can basically set high or low the value of LED2 based on where the LED2 is placed in the development board. Now, if you did everything I told you in the video, we can generate the code, and if everything is correct, we will have a successful build. After that, we can program the board and start communicator with X2C scope to see the reading and the value of the potentiometer, such to decide the right level for the auto switch to turn on and off the LED. So, after programming the board, we can open X2C scope. After opening X2C scope, we can set the port that we want to read, so it will be an I/O port, and it will be potentiometer 1. After doing that, we will sample and see the values read. We see that the middle value is actually not the 0.5 that we are predicting, but it's another value. So we'll have to set the values for the auto switch such to correspond to the values that we're seeing with the X2C scope. In here, I'm doing the needed changes such to have the right threshold up and threshold down, such that when the potentiometer is in one side, then the LED will turn on, and if it's in the other side, it will turn off if it reaches a certain value. After doing that, we can transform model and push communicator again and generate the code again, following the steps I'm showing here. Remember that transform model and push communicator, we have to have the start communication open, so we have to have the X2C block open. After generating the code, we can directly program the board again. After programming the board, we will be able to see that the code that we generated is correct, and as you can see in the video, the LED toggles depending on the position of the potentiometer. I hope that this video was helpful and that it can help you out to do more complex operations with X2C model-based approach.